Hi, this is Dave Thomas. I wanted to show you some samples from the screencasts on the Ruby object model and metaprogramming. The first extract comes from episode 2, where we're talking about different ways of sharing behavior in Ruby. Now, you're probably familiar with inheritance, and maybe you've used mix-ins, but possibly you haven't come across prototype-based development before. In prototype-based development, we don't have classes explicitly. Instead, we just used objects to share both state and behavior. Have a look. In prototype-based programming, we do away with that distinction. Classes and objects are all the same thing. Some people argue that this is actually a purer form of OO than class-based, and there are entire languages based around this paradigm, including JavaScript and Self. Let's play around and see what it looks like. The key to doing prototype-based development in Ruby is the clone method. Let's go to our editor to see how that works in practice. Now, we've seen this code before in episode 1. It defines a singleton method speak on the string that's held in the animal variable. And we can call that by saying animal.speak, and out comes meow. Now, if we take this animal object and clone it, we can then invoke the speak method on that cloned object as well. Because clone copies the singleton class of an object. That's one of the things that makes it different from dupe. If we instead would used dupe here, we get an error, undefined method speak, because the singleton isn't copied across. So using clone, we can copy an object and all of its singleton methods across. And we can use that as the basis of our prototype-based programming. Let's start again, but this time let's try and define a hierarchy of animals. Now, if we're doing class-based programming, we may well have some kind of parent class animal, then subclasses for maybe carnivores or whatever else. In prototype-based programming, we attack it slightly differently. First, we'll create an object that will represent the base functionality of all animals. And we'll just do that by creating a brand new Ruby object. Now, what do we want our animals to have? Well, maybe we'd like to have some attributes, for example, the number of feet they have or what they eat. We can do that simply by defining methods on that particular object. By defining on an animal, we're defining methods that apply to all animals in future. So we can say def animal dot number of feet. We'll create the setter method here, so we'll pass in a parameter. At number of feet equals feet, and we'll define an accessor method as well. And given that, obviously we can now set the attribute on an animal. So we can say animal dot number of feet equals 4, put as animal dot number of feet, and not surprisingly we get 4. But that's not particularly interesting. What's more interesting is if we get rid of this code and let's create a new kind of animal, maybe a cat. And by creating our cat, we can say cat equals animal.clone. That gives us a brand new object that has all of the attributes and all of the behaviors of an animal. So we can also now say cat.number of feet equals 4. Okay, nothing too exciting there. But now we can construct a particular cat. So maybe we can say Felix equals this cat. Now, because we've cloned the object, not only have we cloned the methods, we've also cloned the state. And because of that, Felix will automatically have 4 feet. So what we have here is the ability to have inheritance both of behavior and also of state. In a way, it's more powerful than class-based inheritance. The second extract comes from episode 3, where we look at different ways of creating code dynamically. This is the first time that we've looked at define method, a really useful tool in the metaprogramming arsenal. And yes, I know I misspelled the class multiplier. Let's create for ourselves a new class. And inside that class, self is going to be the class instance multiplier, so define method is available. Let's define the simplest kind of method. We'll say define method. It takes as a parameter the name of the method to define, in this case times2. And it takes a block. And that block becomes the body of the method. If we give that block any parameters, then our method will take parameters. So here we're actually defining a method called times2 that takes a single parameter. And what will it do? Well, we'll just have it return val times2. So as our class definition gets executed, the define method call will create a method called times2. And we can verify that by saying m equals multiplier.new put s m dot times2 3, and sure enough that comes back with 6. But that's nothing special. We could do exactly the same thing with def. What makes define method interesting is we can actually put it inside other methods. So for example here I'm going to define a class method, self.create multiplier. And now our define method will only get invoked if I call create multiplier. So I'm going to say here create multiplier, and our code still runs. But now our create multiplier method can itself take parameters. So for example, I could pass the number I want to multiply through as a parameter to create multiplier. So now I have to take a parameter here. So now we have to rename our method dynamically based on that multiplier. So rather than passing in a symbol, now I'm going to pass in a string, and rather than using a literal 2, I'm going to substitute in the value of our parameter. So that could be 2, 3, 99, whatever it is. Also now I'm not going to multiply by 2, but instead I'm going to multiply by our parameter. Now why does that work? Well, it works because define method takes a block, and that block is a closure, and therefore n is going to be available throughout the lifetime of the existence of that block. And so when I multiply by n in here, I'm actually going to be multiplying by whatever I passed in to my create multiplier method. So now I can just call that, and it still outputs 6. But now I can create a new multiplier, say by 3, and then down here I should have a method called times3. And sure enough, 3 times 3 is 9. That's pretty cool. I can even go further than that. I could say something like 10.times create multiplier I. And now I'll have created times 0, times 1, times 2, times 3, all the way up to times 9. And now we start to see the real power, the real dynamic nature of this kind of metaprogramming. With a single line of code here, plus some support code up the top here, I can add 10 methods to my class. This particular pattern of using define method occurs all over the place when we're metaprogramming, so it's worth studying it. We'll create a class method that in turn calls define method, and typically the parameters of that class method will actually be used either inside the body of the method we define, or to help name the method that we define, or both. I'm really having a blast putting these screencasts together. I hope you have as much fun watching them.